Let us now study a concept of Z value on YDSE screen. About this point here we can write that at any point on YDSE screen other than path difference 0, that is the central maximum point, we can define a numeric parameter such that at that point we have the path difference at this point is P. The path difference at this point is equals to Z lambda, or the value of Z at that point, say it is ZP, and it can be written as path difference divided by lambda. Now in this situation, if the path difference is delta, then Z value we define as delta by lambda. Let's have a look on this picture. This picture shows a specific YDSE setup in which S1 and S2 are the two slits and this is the screen, and point O is the center of the screen, where right now the path difference in the light waves approaching to the point O is equals to 0. Now in this situation, let us analyze a thin film of thickness T and refractive index mu is introduced in the path of one of the slit. Then we already studied the situation that in this situation the whole fringe pattern will shift in upward direction and the central maxima reaches a point which is P, and now here at point P delta is equals to 0, because this is the point where dx by d, if P is at a distance x from the screen center, this is compensating the physical path difference in the two light beams approaching point P, is compensating the path difference introduced due to the thin film, that is T multiplied by mu minus 1. Now in this situation at point O, the path difference is equals to T multiplied by mu minus 1, as the two waves which are reaching at point O will be having same physical path, but the optical path which is due to this film is changed. So this is the path difference at point O. In this situation here we can see if this is the path difference, we can express it in terms of lambda, which we can obtain by calculating the value of Z at point O, which we write as delta at point O divided by lambda, and here this is T multiplied by mu minus 1 divided by lambda. And on calculating this, say for example the value here I am getting is 17.4, say, just for explanation I am taking it. If this value is 17.4, then in this situation here we can write that path difference at point O here is 17.4 lambda. Now in this situation, if this is the point where path difference is 0, this is the point where path difference is 17.4 lambda, then here we can see the point which is having a bright fringe above point O is the one where delta is equals to 17 lambda, and another point which is below O where intensity is maximum or a bright fringe is there, this will be the point below O where delta is 18 lambda, because at O it is 17.4 lambda. So in this situation we can directly see on introducing this thin film, the whole fringe pattern will shift upward in such a way that 17th bright fringe from central maxima is now above the screen center. That means in this situation 17 bright fringes, obviously this is the case when this value is 17.4. 17 bright fringes cross the screen center on introduction of a thin film in front of slit S1. So depending on Z value, once you calculate the Z value at any point on a screen, you can easily find out the order of fringes at the nearest point where you are calculating the Z value for either bright fringes or dark fringes. Bright fringes are obtained where path difference is a multiple of lambda, and dark fringes are obtained where path difference is an odd multiple of lambda by 2.